Hello everyone, and welcome back to the Fluctus Channel. When a fighter jet crashes, runs off a runway, collapses its landing gear, or ends up stranded where it can no longer move, the emergency does not stop when the aircraft does. In many cases, that is when a second mission begins, one just as important as the flight itself. A disabled aircraft can block the runway, shut down sortie generation, create fuel and fire hazards, and leave a multi-million-dollar airframe vulnerable to weather, further damage, or total loss. That is why the US military maintains a specialized system for one purpose above all others: recover the aircraft quickly, safely, and with control.
That's working.
That system is known as CDAR, crash, damaged, or disabled aircraft recovery. CDAR teams are trained to take over when a normal maintenance problem becomes a full-scale operational obstacle. Their mission is not just to move a broken aircraft. It is to clear the runway, reduce secondary damage, protect evidence when an investigation is underway, and restore airfield operations as quickly as possible. In practical terms, they are the crews that turn confusion into procedure. The work is technical, physical, and often urgent, because a single disabled jet can affect an entire base. That is why the training is so intense. CDAR instruction is built around hands-on recovery scenarios, not just classroom briefings. Personnel are taught how to assess a damaged aircraft, choose safe lift points, rig the airframe, stabilize compromised landing gear, and tow it without making the damage worse. In training, they work with crash kits, lifting gear, compressors, hoses, pneumatic systems, and actual aircraft. Everything is designed to reflect the pressure of a real mishap response. One of the most valuable settings for that training is the boneyard, where retired aircraft provide a realistic recovery environment. There, crews can practice on full-size airframes instead of models, learning what it actually means to work beneath a damaged aircraft or around a twisted gear assembly. That realism matters. Recovery work depends on angle, weight, structure, balance, and movement. The boneyard gives crews a place to work through all of that, with real equipment and real dimensions. A major part of the process is low-pressure heavy lifting. When an aircraft cannot stand or roll on its own gear, recovery teams may use pneumatic crash bags placed under selected support points. These bags are inflated gradually to raise the aircraft in a controlled way. This is not a crude lift. It is a carefully managed operation where every inch matters. The goal is to stabilize the aircraft enough to place dollies, jacks, or tow gear underneath it. If the lift is uneven or too aggressive, the structure can shift or collapse further. That is why CDAR teams train to make lifting look slow, deliberate, and precise. towing is just as specialized. A damaged aircraft cannot simply be dragged out of the way. Recovery crews must understand the condition of the landing gear, the strength of the attachment points, and the terrain under the aircraft. Sometimes they tow from standard positions. Sometimes they have to improvise around damage. Different aircraft, different accidents, and different surfaces all demand different methods. That is why CDAR training includes multiple towing setups. The objective is to move the aircraft without turning recoverable damage into total destruction. The equipment used in these operations reflects that complexity. Crash bags, tow bars, dollies, slings, shackles, hoses, manifolds, adapters, jacks, and specialized support gear all form part of the recovery system. Every item exists for a reason. Together, they give the team a way to lift, stabilize, and move damaged aircraft under conditions where ordinary maintenance procedures no longer apply. But some aircraft cannot be recovered by ground crews alone. Sometimes the airframe is stranded in terrain, too remote, too rough, or too unstable for towing and lifting on land. That is where the CH-53K King Stallion becomes a recovery asset. As one of the most powerful heavy-lift helicopters in U.S. service, it can take on jobs that would otherwise require disassembly or abandonment. When a non-flyable F-35C airframe had to be moved, the CH-53K proved exactly what that capability means. A damaged fighter that could not leave under its own power was lifted and transported by air instead. The same principle applied when an MH-60 helicopter was recovered by a CH-53K. In these operations, the helicopter becomes a flying crane. It is not just hauling weight, it is lifting a damaged aircraft that must remain balanced, secure, and structurally stable throughout the movement. That requires careful sling placement, load planning, and close coordination between the ground crew and flight crew. In situations where overland recovery would be too risky or too slow, the CH-53K can remove the aircraft from the site and deliver it to a safer area for inspection or repair. A helicopter crash recovery in water is not just about lift capacity. It is about access, stability, visibility, and the difficulty of working around a submerged airframe. In these cases, the operation expands beyond aviation crews and becomes a broader rescue and salvage effort. Boats, divers, lifting teams, and emergency responders all become part of the mission. And that is what makes damaged aircraft recovery so remarkable. On the ground, CDAR teams bring control to runway chaos with lifting bags, tow gear, and specialized crash kits. In more remote conditions, helicopters like the CH-53K take over, lifting damaged airframes where vehicles cannot reach. From runway mishaps to airlift extraction and water recovery, the process is never simple, but it is always built on the same principle: recover the aircraft, protect the mission, and keep the crisis from getting any worse. And if recovering a damaged aircraft on land is already difficult, recovery at sea becomes even more unforgiving. Once a fighter goes down in the ocean, the mission expands from aircraft recovery into full-scale search, rescue, and salvage. Time immediately becomes one of the biggest factors. In the first hours after a crash, helicopters are often the fastest way to search wide areas of open water. Look for survivors and begin building a picture of where the aircraft may have gone down. That is why MH-60S Seahawk helicopters are so important in overwater recovery efforts. They can launch quickly, cover large distances, coordinate with ships below, and keep searching while the rest of the response force positions itself. But sea searches are slow by nature. Debris drifts, visibility changes, weather interferes, and the search area can expand rapidly depending on current and wind. What seems like a direct rescue effort can quickly become a race against distance, daylight, and the ocean itself. That reality was clear in the aftermath of an FA-18 crash, when Navy divers and salvage teams became central to the recovery operation. Once a fighter goes beneath the surface, recovery enters a completely different phase. It is no longer about runway clearance or sling, loading a damaged airframe out of rough terrain. It becomes a problem of depth, pressure, visibility, and underwater access. The aircraft has to be found, inspected, secured, and then prepared for lifting without tearing it apart or losing key evidence. That is where Navy divers step in. Their work is highly technical and physically demanding. They descend into dark water, locate the wreck, assess its condition, and attach the equipment needed to bring it back. In many ways, they become the link between a lost aircraft on the ocean floor and the team waiting above to recover it. These divers do not operate in isolation. They are part of a much older Navy salvage tradition shaped by decades of hard-earned experience. One of the deepest foundations of that tradition came after Pearl Harbor, when Navy divers undertook some of the most difficult salvage work in U.S. military history. They worked through oil, debris, unstable wreckage, unexploded ordnance, and low visibility to recover and restore damaged ships after the attack. That period helped define the seriousness and professionalism of Navy diving and salvage operations for generations afterward. Today's teams use more advanced equipment, but the mission remains familiar. Go where the aircraft is lost, no matter how hostile the environment, and recover what can still be saved. When flyers launched from USS Hornet under extraordinary pressure to modern carrier operations, flying from and over the sea has always meant narrow margins and hard consequences when something goes wrong. That is why recovery is not treated as an afterthought. It is built into preparedness from the start. Nowhere is that more visible than in today's flight deck crash and salvage drills. On an aircraft carrier or amphibious ship, there is no waiting for outside help. If a jet crashes, catches fire, breaks apart, or blocks the deck, the crew must respond immediately with its own equipment and training. These drills teach sailors how to secure the scene, move damaged aircraft, control fire risk, and restore the flight deck to operational use as quickly as possible. A carrier's deck is too valuable, too crowded, and too active to leave blocked for long. Part of that response capability comes from equipment such as the crash crane. This specialized deck asset is used to move damaged aircraft and heavy debris when a normal tow is impossible. On a moving ship in limited space, that kind of lifting capability is essential. So too are underwater ROVs, or remotely operated vehicles, which help salvage teams inspect submerged wreckage before divers go below. ROVs provide location, orientation, and hazard awareness, allowing divers and planners to work with better information and less risk. Put together, this is the full recovery chain. Helicopters search, divers descend, ROVs inspect, crash cranes clear decks, salvage teams secure wreckage. And the mission continues until the aircraft is found, recovered, or accounted for. From the runway to the ocean floor, the process is never simple. But it is always built around the same objective: restore control, protect capability, and make sure one crash does not become a larger failure. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.